Clear my point?
Yes, ma'am.
So, first of all, I will tell you the series of a step procedure and how to prepare our solution. Then after that, I will show you the experimental video of this. Clear?
Okay, ma'am.
Clean are visible?
Yes, ma'am.
Correct. Isolation of DNA from plant cells. Sorry, plant leaves. Just wait 1 minute. Isolation of DNA from plant leaves. Okay. So here's the total work. Total plant leaves. Okay. So first of all, we have to prepare a stock solution for this experiment. So do you know that stock solution?
Yes, ma'am.
What is the stock solution?
It's a concentration high
Concentration.
होता है high होता है
So the stock solution that we have to prepare here is HCl, whose pH will be 8 and concentration is 1 mole. Second is your EDTA, whose pH is again 8 and concentration is 0.5 mole. Third is your potassium acetate, whose pH is 7 and okay, concentration is 5 mole. Fourth is sodium chloride, whose concentration is 5 mole. In sodium chloride, you don't require to prepare to maintain its pH. HCl 10 points. Okay. Now, first solution that you have to prepare is your first HCl 1 molar. Okay. Now you have to prepare first HCl for 10 ml. Okay. And the molecular weight of the test HCl is 157.60 grams per mole. Now calculate the weight of the HCl for 10 ml. Calculate this.
1.67.
1
67. 6.
which formula? Can you please tell me the formula
किसका मैम
for the calculation of viscous HCl? If you have to calculate the weight of the first HCl, whose molecular weight is 157.60 grams per mole and volume is 10 ml and the concentration is 1 molar. So this formula we use here. Simply we use this formula for all these for the preparation of all these solutions. Okay, here except FDS. That is weight is equal to molecular weight multiplied by molarity multiplied by volume given. And if the volume are given in ml, then we have to divide the formula with 1000. Okay. Now put all these values into the formula. That is your 157.60 multiplied by Varun, please mute yourself.
क्या हुआ मैम?
Please mute yourself. Multiplied by 1 multiplied by 10 divided by 1000. When you solve this, you will get 157.60 multiplied by 1 multiplied by 10 divided by 1000. 1.576. 1.576 gram this HCl will be dissolved into the 10 ml of the distilled water. Then you get what? You get 1 molar of this HCl. Clear my point?
Yes, ma'am.
Any doubt?
No, ma'am.
This will have the same this formula. You have to calculate the weight of the EDTA for 100 ml. And the molecular weight of the EDTA is 292.24 gram per mole. Clear? Again, you have to use this formula. 0.5 multiplied by 292.2 multiplied, sorry, 290, 292.24 multiplied by 100 divided by 1000. So you will get 14 gram, 14.61 gram of EDTA in 100 ml of distilled water. Then you get a concentration 0.5 molar. Same with the potassium acetate. The molecular weight of the potassium acetate is 98.14. Okay. And you have to prepare it for 100 ml. So molecular weight is 98.14 multiplied by 5 multiplied by 100 divided by 1000. That is
49.07.
exactly. It is 49.07 gram of this potassium acetate will be dissolved into 100 ml of the distilled water. Then we get what? We get the 5 molar of potassium acetate. The last one is your sodium chloride, whose molecular weight is 58.44 and the volume will be again 100 ml. Okay. Then what you have to do? Put all these values into the formula. That is your 968
29.22.
29.22 grams will be dissolved into 100 ml of distilled water. Then we get what? We get 5 molar of sodium chloride. Now, one more thing that I have to add here. In the first chemical, you have to maintain the pH of the this HCl, pH of the EDTA, and pH of the potassium acetate. For this, what you have to do, first of all, you have to dissolve this weight. Okay, this 157.6 gram weight into the 10 ml of the distilled water, and after that, you have to maintain its pH. That is 7. Clear?
Ma'am, how exactly we maintain pH?
How exactly you maintain pH means that
What we add or what we मतलब-
well, this is a skill pH. Okay. Then the dangerous pH is some around 3 or 2, right? So means that it is acidic, and you have to maintain it with till it reaches to the pH 8. For this purpose, you have to add and base into it, increase its pH from 3 to 2 to 8. Okay, base means that NaOH. Clear?
Yes, ma'am.
Suppose that its pH is more than 8, like
Mm-hmm.
then in that case you have to add a sub acid so that its pH will reduce to the 8. Clear?
Yes, ma'am.
Same when you prepare this PDP and we require around 1 gram of EDTA. But in that case, there is something different because this is large amount. So you have to prepare it for 100 ml. For this case, what you have to do, first of all, you have to dissolve this 45 grams into 50 ml of distilled water. Okay. Then maintain pH same pH 8. After that, add the remaining 50 ml of the distilled water and make a volume to 100 ml. Here, first dissolve 14.61 gram of EDTA into 50 ml of the distilled water and maintain its pH. After maintaining its pH, when it reaches to the 8, then add 50 ml of the distilled water. Same with the potassium acetate, dissolve this 49.67 gram of potassium acetate into the 50 ml of the distilled water. Then maintain its pH 7. When the pH is maintained, then add remaining 50 ml of the distilled water. Here,
Yes, ma'am.
this is how you prepare your test. One more thing, you have to prepare this SPF 10%. Suppose that you prepare this 10% for 50 ml. Now what you have to tell me? If you have to prepare the 10% of the SPF for 50 ml, then how you prepare? Mhm. So you have to convert this percentage into fraction 10 by 100 and multiply by given volume. 0
5
can
gram.
yeah, right. Take 5 grams of SDS and dissolve into the 50 ml of this water. This is how you prepare the soft solution. Now, after the preparation of this soft solution, you have to prepare the working solution with the help of the soft. Now, the next is here preparation of the working solution. Okay. So, the soft solution that you prepare is extraction buffer. the solution. The first is your HCl. Now, the extraction buffer, the final volume of the extraction buffer will be 15 ml. Okay. So you have to heat this HCl. Whose concentration is 100 millimolar. And the second is your EDTA, whose concentration is 50 millimolar. Third is your sodium chloride, whose concentration is 500 millimolar. Fourth is your SDS, 1.5%. And the last one is your beta ethanol. Zero point 0.25 ml. Okay. Now, here solution are liquid. Okay. Because you the solution, right? This solution has the conversion of the stock into the working. Anybody remember?
M1V1 is equal to M2V2.
Yeah, right. M1 V1 is equal to not M1 V1, we use T1 V1. M1 V1 is for the liquid reagent. Okay, when you have to when the solute is liquid, okay. Here you have to convert your stock into working. In that case, you use the formula C1V1 is equal to C2V2. Right. Now you have C1V1 is what? The concentration of stock and volume of stock, and C2V2 is what? It is the concentration and volume of
Working.
concentration volume of working. To do, we have C2V2, right? We have C2V2. For this HCl, C2 is equal to 100 millimolar and V2 is equal to 50 ml. Right? And we also have C1 in case of the this HCl. That is your 1 molar. This is the concentration of the stock. C1 is the 1 molar. So you have to calculate the V2. Okay. One more thing here. Units of the concentration are not same. You see that C2 are given as millimolar and C1 are given as molar, right? So in that case, you have to convert the concentration of the solution. Okay. Now we know that 1 molar is equal to 1000 millimolar or 0.5 molar is equal to 500 milliliters. Okay. So where 1 molar are there, we put 1000 millimolar in the place of the 1 molar. Right? Right?
Yes, ma'am.
Yes, ma'am.
Simply, what we have to do, we use this formula by rearranging V1 is equal to C2V2. C2V2 means 100 multiplied by 50 divided by C1, that is your 1000. That is your 1000. Now solve this. V1 is 5 ml in case of Swiss HCl. Okay. Now what you have to do, take a measuring cylinder of 50 ml and add 5 ml Swiss HCl into it. Now solve NaCl, NaCl. You can use same formula, okay? Like in case of EDTA, V1 is equal to P2V2 means 50 millimolar multiplied by 50 divided by 0.5 molar. Then we convert this 0.5 molar into millimolar, that is your 500. 0 cancel 0, 0 cancel 0, 5 cancel 5. So V1 is what? 5 ml. Yes, that means that we require this EDTA 5 ml. Now put the EDTA 5 ml into the beaker. Here, clear or not?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Now, next is your sodium chloride. In case of sodium chloride, V1 is equal to 500 multiplied by 50 divided by sodium chloride concentration is 5 molar. This converted into the 5000 millimolar. 0 cancel 0, 0 cancel 0, 5 cancel 5, that is 5 ml. So we add 5 ml. Sodium chloride, right? Then prepare 1.5% of HCl with this solution. So you have 50 ml of solution. So simply what you have to do? Take 1.5 ml and put it to this. Not 1.5, 15 ml. Hmm. Serve it like this. 1.5 100 multiplied by 50. One point two five divided by 100 multiplied by 50. 0.7. Take 0.5 ml, 0.75 ml. Zero point 0.75 ml SDL and 0.25 ml beta marcaptor ethanol. After that, make a volume 50 ml with the help of the distilled water. Make a volume 50 ml with distilled water. Clear? Get clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Clear, right? Now, after that, you have to prepare the calcium acetate solution. The potassium acetate solution. Okay, so for this we require this potassium acetate solution will be prepared for 100 ml. Okay, so for the preparation of the potassium acetate solution, we require potassium acetate, which is already prepared 75 ml. Then we require glacier acetic acid, 13.5 ml. Then we require distilled water, 11.5 ml. Okay. Then after that, we have to prepare our last ingredient, that is your fifth EDTA buffer. It is also the part of the working solution. Okay. The first working solution is extract buffer. Then you have to prepare a potassium acetate solution. Then you have to prepare a fifth EDTA buffer. Okay. So the first chemical is your fifth HCl and the second is your EDTA. So this HCl will be required 100 millimolar. Am I audible?
Yes, ma'am.
Okay. This HCl will be required for again for 50 ml and EDTA of 10 millimolar is also required. So the final volume of this EDTA will be 50 ml, not less. The final volume of this EDTA buffer will be 50 ml. Okay. So this HCl will be required 100 millimolar and EDTA will be required 10 millimolar. Okay. So again, we have to take that detail. The concentration of the this HCl for 100 millimolar is already calculated. That is your 5 ml. So put it here. 5 ml. This is HCl. Then calculate it for 10 millimolar. So V1 is equal to 10 multiplied by 50 divided by 500. That is 1 ml. 1 ml EDTA. After that, make up volume 50 ml. With the help of the distilled water. Make up volume 50 ml with distilled here. Here.
Yes, ma'am.
Now, the last chemical that we require, which is not be prepared but we require is that is your 70% of the ethanol. Is ethanol, okay? 70% of this is ethane. Clear? Now, when we start our procedure, this procedure are completed into this 5 steps. Now, step 3, DNA isolation. Okay. Then, which step? The first one is your lysis, then purification. After that, precipitation, then washing, then storage. Here,
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
isolation technique. Now, we have to choose a lead for the DNA isolation. So we choose a baby leaf. Why we choose the baby leaf? Let me tell you. First, we require a leaf. That is your baby leaf. Okay. We choose these baby leaves because their merit is soft. So their mid-strip is soft. Mid-strip is soft. Now, what is mid-strip? Suppose that this is your leaf. So this line is known as the mid-strip. Okay, if we choose these baby leaves, then their mid-strip is soft. Okay. And baby leaf is what? It is the new leaf. Here, and if we choose a big leaf, then we have to remove the mid step. Then after that, we will start the procedure. Then after that, we will start the procedure. Clear my point?
Yes, ma'am.
Now, we have to wash the leaf with tap water, then wash with distilled water. After that, tap dry. Okay, what is tap dry? You have to take a filter paper like this and just put your leaf here. And with the help of the another filter paper, you have to tap it into the leaf and soak the water. This is known as the tap drying. Here,
Yes, ma'am.
okay. Then after tap drying, you have to weigh it. Now, when you are weighing, you have to take at least 2 grams of the leaf. If you take less than 2 grams, then it is not sufficient. Here, after weighing simultaneously, you have to pre-warm the extraction buffer. Pre-warm the extraction buffer. Okay. Now transfer these leaves into the water pistol. Water pistol, and along with it add the 10 ml warm extraction buffer. Okay. When you added these extraction buffer, you have to add slowly. Okay. Because if you add like in at once all the extraction buffer into the mortar pistol, then calorie is formed. Calorie is formed. So we have to avoid this calorie and paste will be formed. In that case, what we have to do, we have to add this extraction buffer slowly. Clear?
Yes, ma'am.
Yes, ma'am.
Now this process when you are like converting the leaf into the paste is known as the lysis method. Okay. So here the first step is completed. That is your lysis. In lysis, what you have to do, you break the wall. That's why it is known as the lysis. Then after that, you have to trans sorry, not transfer. You have to incubate it at 65 degrees Celsius for 10 minutes in water bath. Now, what you have to do, you have to set that water bath temperature 65 degrees Celsius and put it into the put it into it for 10 minutes and do a inversion for 2 times at every 5 minutes. Okay? Then after that, you have to add 0.5 ml potassium acetate solution. This solution is potassium acetate solution, okay? And you have to put it at, keep it at ice for 10 minutes. Okay. Now this process is known as a purification. The second is purification. Why it is known as a purification? Because once you increase its temperature, then suddenly you decrease its temperature. That's why this is known as a purification. After that, you have to centrifuge it. Centrifuge it at 10,000 RPM for 20 minutes. When you centrifuge it at 10,000 RPM for 20 minutes, you will get two things. One is your supernatant and another one is your palette. You have to discard these supernatant and in palette you have to add 200 microliter pure ethanol. Here, now this process, when you get this, when you do the centrifuge and get supernatant and palette, this process is known as the precipitation. Here, then
Yes, ma'am.
you have to flip that means that suppose that this is your append drop and here the DNA are there. So what you have to do, you have to cut the wall of the append drop so that these DNA will mix into the ethanol. Then after that, again you have to do a centrifuge at 8,000 RPM for 10 minutes. When you get what? Again you get supernatant and the talent. Supernatant and talent. Discard this supernatant. And into talent you have to air dry its talent. Why the air dry? So that the smell of the ethanol will remove. Clear? When the smell of the ethanol is removed, add 100 microliter of PE buffer and incubate it at 65 degrees Celsius for 1 hour and water bath. Then after that, store it at refrigerator. When you discard this supernatant after the second centrifuge, this process is known as a washing. So this is all about the isolation of the DNA from plant leaves. It is clear?
Ma'am, can you explain the
Process again.
Now, procedure will start here. You have to take a leave. So we prefer a baby leave to this process. Okay, why we prefer the baby leave? Because the middle stress of the baby leave is short. That's why we take a baby leave. Baby leave means that we always take big leave, but we have to remove it mid-skip, then we have to perform our experiment. Okay. Now what we have to do, we wash that leaf with the help of the tap water. Then we wash it with the distilled water and we stand dry. After stand dry, we spray the leaf, please 2 grams. Okay. And meanwhile, at simultaneously, we warm the extraction buffer. Then we transfer these leaf into the mortar tester and we add these extraction buffer slowly into the mortar tester. And the volume of the extraction buffer will be 10 ml. For 2 grams of the leaf, the volume will be 10 ml. So, if we add and work all these extraction buffer into the mortar system, then calories will form, which is not suitable. Then we incubate it at 55 degrees Celsius for 10 minutes in water bath. Then we perform the inversion at every 5 minutes. After that, when we remove it from the water bath, we added the 0.5 ml of the potassium acetate solution and we kept it at ice for 10 minutes. Then we centrifuge it at 10,000 RPM for 20 minutes. We get supernet and pallet. We discard these supernet and in pallet we add 200 microliter of chilled ethanol. Then the DNA will stick on the wall of the apple box so that also for this purpose we do a flip tap so that this DNA will mix into the solution. Clear?
Yes, ma'am.
Then again we perform centrifuge at 8,000 RPM for 10 minutes and we get what? We get supernet and pallet. We discard that supernet and in pallet we air dry it. Why we air dry it? So that the smell of the ethanol will remove. Then after that we incubate it at 65 degrees Celsius inside the water bath for 1 hour and then we keep it at refrigerator and that white pallet is known as the DNA. Then we use this white pallet for a further use. Here the TE buffer is used for the storage purpose. Clear? Now it is clear?
Yes, ma'am.
Yes, ma'am. Ma'am, what is the reason behind to remove the midrib?
Your voice is not clear. Can you please repeat it?
What is the reason behind to remove the midrib at first stage?
Synthesis would be isolation of the DNA. That's why we remove that link.
Okay.
Okay, now?
Yes, ma'am.
Okay. Now I'm going to start the experimental video. These experimental video, you can see that experimental video, and if you have any view, just let me know. When you see the experimental part, then it will be very easy for you to understand this topic.
हेलो एवरीवन, आज हम करेंगे डीएनए का एक्सट्रैक्शन फ्रॉम अ प्लांट लीव। इसके लिए जो हमें स्टॉक सोल्यूशन चाहिए उसमें चाहिए ट्रिस HCl 1 मोलर का जिसका pH 8 होना चाहिए। इसका सारा कैलकुलेशन मैं आपको क्लास में बताऊंगी। दूसरा हमको चाहिए EDTA 0.5 मोलर का जिसका भी pH 8 होना चाहिए। 10% SDS होना चाहिए। 5 मोलर सोडियम क्लोराइड होना चाहिए और पोटेशियम एसीटेट जिसका pH 5 मोलर जिसका pH 7 होना चाहिए और मोलारिटी जो है वो 5 मोलर होना चाहिए। ये सारे कैलकुलेशन मैं आपको क्लास में बताऊंगी। इसके बाद इनसे हम लोग बनाते हैं अपना एक्सट्रैक्शन बफर। एक्सट्रैक्शन बफर में आपका ट्रेस HCl होता है, EDTA होता है, NaCl होता है, SGS होता है और बीटा परसेप्टो इथेनॉल होता है और बाकी इसमें डिस्टिल वाटर होता है। ये हम 50 ml बनाते हैं। ये सारे कैलकुलेशन मुझे आपको क्लास में बताना है कि किस तरह से करना है। फिर हम लोग बनाते हैं पोटेशियम एसीटेट सोल्यूशन। पोटेशियम एसीटेट सोल्यूशन में जो है वो पोटेशियम एसीटेट होता है 75 ml और ग्लेशियर एसिटिक होता है 13.5 ml। ये जो कंपोजिशन हम बनाते हैं ये 100 ml के लिए बनाते हैं, तो बाकी जो रेस्ट होता है वो उसमें डिस्टिल वाटर होता है। इतना हमारा सोल्यूशन जो है वो प्रिपेयर हो चुका है। और एक और होता है जिसे हम लोग कहते हैं ट्रिस EDTA बफर। इसमें ट्रिस HCl होता है जिसका pH 7.5 होता है और EDTA होता है जिसका pH 8 होता है। अब हमको सैंपल के लिए क्या चाहिए? सैंपल के लिए हमें एक बेबी लीव्स चाहिए। ये हमने जो है बेबी लीव्स ली हुई है। आप बिग लीव्स भी ले सकते हो, लेकिन उसमें आपको जो है जो मिड ट्रिप होगा उसको रिमूव करना पड़ेगा। बेबी लीव्स की जो मिड ट्रिप होती है वो बहुत ही सॉफ्ट होती है। तो सबसे पहले इसको हम लोग वॉश करेंगे टैप वाटर से। अब हम वॉश करने जा रहे हैं अपनी बेबी लीव्स को टैप वाटर से, ताकि इसका जो भी डस्ट वगैरह हो वो सब चीज रिमूव हो जाए। अब हमने टैप वाटर से इसको वॉश कर लिया। अब हम इसको वॉश करेंगे डिस्टिल वाटर से। डिस्टिल वाटर से अब हम वॉश करने जा रहे हैं अपनी बेबी लीव्स को। आप जब टैप वाटर से वॉश कर लेंगे उसके बाद ही हम डिस्टिल वाटर से इसको वॉश करेंगे। अब हमारी लीव जो है वो वॉश हो गई है। अब इसको हम लोग जो है फिल्टर पेपर पे रख के इसको ड्राई करेंगे। अब हम फिल्टर पेपर पे इसको रख रहे हैं ताकि जो है जो भी इसके अंदर वाटर कंटेंट है वो रिमूव हो जाए। जब इसका जो है वाटर कंटेंट रिमूव हो जाएगा, ये ड्राई हो जाएगी, तो हम मॉर्टर पिस्टल का यूज करके उसको क्रश करेंगे और उसमें हम लोग एक्सट्रैक्शन बफर डालेंगे। लेकिन जो क्वांटिटी होगी वो धीरे धीरे हम उसमें डालेंगे।
This is known as a front. Okay. These are straight into the filter paper and with the help of the another filter paper we wrap it. So that the milk is easily removed.
अब ये ड्राई होने के लिए हम इसको छोड़ देंगे। हमारी लीव जो है वो एयर ड्राई हो चुकी है। अब इसका हम लोग जो है वो 2 ग्राम वे करेंगे और एक्सट्रैक्शन बफर को हम लोगों ने 60 डिग्री पे प्री वार्म होने के लिए रख दिया है 10 मिनट के लिए। तो वे करने के लिए सबसे पहले हम क्या करेंगे, अपना वेइंग बैलेंस ऑन करेंगे। फिर एल्युमिनियम फॉइल पे रखेंगे, इसका वेट टेयर करेंगे। फिर जो हमारी लीव जो एयर ड्राई हो चुकी है उसको वे करेंगे। जैसे ही 2 ग्राम आ जाएगा हम फिर छोड़ देंगे। ग्राम वे आ गया है। अब डोर क्लोज कर देंगे ताकि जो है कोई भी फ्लक्चुएशन ना हो। अब इसको हम लोग ट्रांसफर करेंगे मॉर्टर पिस्टल में। ये है हमारा मॉर्टर। अब इसमें हम ऐड करेंगे प्री वॉर्म एक्सट्रैक्शन बफर 10 ml, वो भी धीरे धीरे, और फिर इसको हम क्रश करते जाएंगे और धीरे धीरे अमाउंट में इसको ऐड करते जाएंगे। सबसे पहले हम क्या करेंगे, अपना एक्सट्रैक्शन बफर जो है वो 10 ml मेजरिंग सिलेंडर से वे कर लेंगे। ये हो गया हमारा 10 ml एक्सट्रैक्शन बफर। अब इसको धीरे धीरे क्या करेंगे, हम लोग मॉर्टर में ऐड करेंगे और पिस्टल से इसको क्रश करेंगे। पूरा अमाउंट एक साथ ऐड नहीं करेंगे, नहीं तो क्रश नहीं हो पाएगा और जो हमें टेस्ट चाहिए वो नहीं बन पाएगा। ये देख सकते हैं कि लीव हमारा क्रश होना स्टार्ट हो गई है। थोड़ा सा अमाउंट हम इसमें ऐड करेंगे। हम लोग इसलिए करते हैं ताकि इसके सेल्स जो है वो ब्रेक डाउन हो जाए। फिर थोड़ा सा अमाउंट ऐड करेंगे। देख सकते हैं हमारा पेस्ट जो है वो रेडी हो गया है। पूरा बाकी जो है वो ऐड कर देंगे और अब हम चलेंगे नेक्स्ट प्रोसेस के। सैंपल हमारा क्रश हो गया है, उसको हम लोग 1 ml जो है अपने एपन ड्रॉप में ट्रांसफर करेंगे। ट्रांसफर करने के लिए हम क्या यूज करेंगे, माइक्रो पाइपेट। इसी तरह से हम दूसरे में भी ट्रांसफर करेंगे। हमारे 10 एपन ड्रॉप जो है वो रेडी हो गए हैं। सॉरी 3 एपन ड्रॉप जो है वो रेडी हो गए हैं।
ऊपर से
हमने अपना सैंपल जो है वो लोड कर लिया है। अब इसको हम लोग जो है 10 मिनट के लिए इंक्यूबेटर में रखेंगे 63 डिग्री सेल्सियस पे। सॉरी 10 मिनट के लिए वाटर बाथ में रखेंगे हम लोग इंक्यूबेट होने के लिए 63 डिग्री सेल्सियस पे। ये हमारा सैंपल है जो कि अपन ड्रॉप में ट्रांसफर हो चुका है। ये हमारा जो है जो सैंपल हमने रखा था जो है वाटर बाथ पे इंक्यूबेट करने के लिए वो हो चुका है। अब इसमें हम जो है 1 ml पोटेशियम एसीटेट सोल्यूशन जो है वो ऐड करेंगे। ये सैंपल को रख देंगे आइस में फॉर 10 मिनट एट 4 डिग्री सेल्सियस। इसमें हमने पोटेशियम एसीटेट सोल्यूशन ऐड कर दिया है। अब इसको हम जो है 10 मिनट के लिए 4 डिग्री सेल्सियस पे रखेंगे। उसके बाद हम इसको सेंट्रीफ्यूज करेंगे। अभी हमने अपने जो है सैंपल को जो है 4 डिग्री सेल्सियस पे रखा था 10 मिनट्स के लिए। अब ये इसको हम लोग जो है सेंट्रीफ्यूज करेंगे 10,000 आरपीएम पे 20 मिनट्स के लिए। फिर देखते हैं क्या चेंजेस आते हैं उसके अंदर। ये है हमारा सेंट्रीफ्यूज, मिनी सेंट्रीफ्यूज। इसमें हम अपना एपन ड्रॉप जो है वो इंसर्ट करेंगे और हमेशा पैरेलल ही रखते हैं। ये सारे एपन ड्रॉप हमारे इसमें ऐड हो गए। अब हम लोग इसको 20 मिनट के लिए सेंट्रीफ्यूज कर देंगे। फ्यूज करना हम लोगों ने 10,000 आरपीएम पे स्टार्ट कर दिया है। अब इसको हम लोग 20 मिनट तक जो है सेंट्रीफ्यूज करेंगे। उसके बाद जो सुपरनेंट आएगा उसको हम लोग डिस्कार्ड कर देंगे और जो पैलेट आएगा उसके साथ आगे प्रोसेस करेंगे। हमारा सेंट्रीफ्यूज का प्रोसेस जो है वो कंप्लीट हो गया है। ये हमारा सुपरनेंट आ गया है।
When you filter these after that testing, this green line, that the green color that certificates are there, then it will not be open. Okay, only the white color. You can see that the white color on this green certificate. Only this will be useful. So after testing, what you have to do, you filter it. Then after that, you have to fill it into the cupping drop.
और ये वाइट पैलेट्स आप देख रहे हैं, ये हमारा डीएनए है। अब क्या करेंगे, हमारा जो सुपरनेंट है उसको हम लोग डिस्कार्ड कर देंगे, 1 बाय 1 करके डिस्कार्ड करेंगे। और बहुत ही इसमें केयरफुली डिस्कार्ड करना होता है ताकि जो है जो हमारा जो है डीएनए बना हुआ है वो डिस्टर्ब ना हो। पूरा सुपरनेंट आपको डिस्कार्ड करना है। तो देखिए पूरा सुपरनेंट जो है वो डिस्कार्ड हो गया है। अब इसी तरह से हम सारे एपन ड्रॉप का सुपरनेंट जो है वो डिस्कार्ड कर देंगे और वाइट पैलेट जो है वो छोड़ देंगे। अब हम इसमें 200 माइक्रोलीटर जो है 70% कूल इथेनॉल जो है वो ऐड करेंगे सारे एपन ड्रॉप में। इथेनॉल डालने के बाद हम इसको टैप करते हैं ताकि जो भी चीज़ें हों वो मिक्स हो जाए। इसे कहते हैं फ्लिप टैप। ये सारे टेस्ट ट्यूब के साथ सारे जो है एपन ड्रॉप के साथ करेंगे और उसके बाद इन्वर्जन करेंगे हर एपन ड्रॉप को 1 मिनट तक। ऐसा इसलिए करते हैं ताकि जो भी वॉल पे लगा हो वो डीएनए स्विम करने लगे। हम इसको दोबारा 10,000 आरपीएम पे सेंट्रीफ्यूज करेंगे फॉर 10 मिनट। ये वॉश हो गया है और यहाँ पे हमारा जो है डीएनए सैंपल आ गया है। अब जो इथाइल अल्कोहल है उसको हम डिस्कार्ड कर देंगे और फिर इसे हम एयर ड्राई होने देंगे। एयर ड्राई तब तक करेंगे जब तक इसमें से इथेनॉल की स्मेल खत्म नहीं हो जाती है। हमने सुपरनेट अब जो है पूरा डिस्कार्ड कर दिया है और हमारा बैंड एकदम क्लियरली शो हो रहा है। अब इसको हम एयर ड्राई करने के लिए छोड़ देंगे। करने के बाद हम इसमें जो है ट्रिस ईडीटीए ऐड करेंगे और इसको इंक्यूबेट करेंगे 1 आवर के लिए वाटर बाथ में 60 से 65 डिग्री सेल्सियस पे। और जो ईडीटीए ऐड करेंगे, ट्रिस ईडीटीए बफर जो ऐड करेंगे हम वो ऐड करेंगे 100 माइक्रोलीटर। ये हमने इसमें ऐड कर दिया है और अब इसको हम जो है वाटर बाथ में इंक्यूबेट कर देंगे 1 आवर के लिए।
So this is all about the experiment. Anybody have any doubt?
No, ma'am.
Anybody?
No, ma'am.
Everything is clear? So,
Ma'am,
Ma'am.
ma'am, I have a doubt.
yes.
Ma'am, I want to understand what is happening at molecular level when we do the process. Like when we do lysis, then we prepare a homogenate of cell.
Yes.
And when we purify, like when we incubate in water bath, then what happened? Why exactly we do that process?
This question is, you are asking this one. You are saying that when we do our lysation, we break the bond, right?
Yes, ma'am.
So this is incubator for a heating purpose, okay? Because when we heat it and suddenly we decrease its temperature, let's see. Here, you heat its temperature, like it reaches to 65 degrees Celsius, okay?
Mm-hmm.
Suddenly you add that potassium acetate and then you like decrease its temperature, okay? So this means that you give the shock to that cell. And by this way, you purify the cell. That's why we incubate it for the purification process.
So, ma'am, what we exactly obtain after purification? Like DNA is there, of course, and other cell organelles are also there.
During purification, what happens? Other elements like which cannot be tolerated at that higher temperature will remove out from the particle. It will remove out that state, and when you do a centrifuge, completely separate out. That's why we do a purification. If you have a, okay, in case when you decrease its temperature and then again you added the potassium acetate. So there are some impurities that are present into your substance. Use that
Mm-hmm.
use that substance, and when you do that centrifuge, it's completely remove out from your paste, and you get what? You get this palette, which is very purified form of that DNA molecule.
Okay, ma'am. Ma'am, I have one more doubt. In isolation, DNA isolation, in theory, what I have studied is the phenol chloroform method and all. So, ma'am,
This is
why it is so different?
this is another type of the method for the for the isolation of the DNA. You can also use that method. In our laboratory, we use this method for the purification of the DNA. Sorry, for the isolation of the DNA.
Okay, ma'am. Okay, ma'am. Yes, ma'am.
Anything else?
Ma'am, why we do the centrifuge second time?
First, for a confirmation, why we do that centrifuge for the second time. Okay. Any impurities remain for the first time after first time of the centrifuge. So that impurities will be removed when we do a second time of the centrifuge.
Ma'am, I have one more doubt. How are we exactly ensuring that there is only DNA, not RNA is present, only DNA?
After doing that agarose gel electrophoresis. If you get that back, then it is clear that it is a DNA. It is
Okay.
confirmed by the method of that agarose gel electrophoresis.
Mm.
Ma'am,
Okay.
even in agarose gel electrophoresis, there will be the existence of DNA. After treatment of alkali, there is a RNA, formation of RNA.
Please say it again because it is not clear.
Even in gel electrophoresis, there is existence of DNA there. After treatment with alkali, there is formation of RNA.
I write your question. We'll tell you tomorrow.
Okay, ma'am. And ma'am, what is